Hi everyone, welcome to my tutorial on van der Waals forces. So to understand van der Waals forces, first we need to look at our atomic models. If you remember from your previous chemistry studies, you've got the first model that we're going to look at is the Rutherford model. Here it comes just now. So what we have in the Rutherford model is basically the nucleus in the middle. You can see the circle in the middle of the atom there, and the electrons orbiting round in nice little circles in their energy shells. So in that particular one, I think that's lithium. You've got 3 electrons altogether. But really, in our more quantized model, what actually happens is the electrons move around absolutely randomly around the nucleus. They can be on one side, they can be on the other, they can be absolutely anywhere, and they can move from one spot to another pretty much instantaneously. So that means actually that in an atom, it is possible that one side of the atom can have more electrons than the other. If it's got more electrons on one side, like this one on the left, then you're going to have a delta negative charge, a more negative charge on that side. And conversely, on the other side of the atom, there's going to be a more positive charge. So what happens when another atom gets close to that? Okay, if it gets close to it, the positive part of the atom on the left is going to attract more electrons towards it, making the atom next to it also have a dipole, i.e. having more charge on the left-hand side than on the right-hand side, more negative charge. Okay, we know what negative and positives do to each other. They attract. So this sets up a small force of attraction between those two atoms. There it is, force of attraction. Okay, so that is our van der Waals force, a very small force of attraction caused by instantaneous dipole, induced dipole. So the instantaneous dipole from the random movement of electrons on the left, so on. Okay, factors of force affecting our van der Waals forces. The size of the atoms is a big factor when determining the size of the van der Waals force. Small atoms only have a small number of electrons, so they can create quite small van der Waals forces between the atoms. So what we will find there is that they have lower melting and boiling points. Bigger atoms, many more electrons, much more chance of a bigger dipole on the atom, so you're going to have a larger force between the atoms. Also, the size of the molecules, in much the same way, small molecules only have a small amount of electrons, so they have quite small van der Waals forces. Larger molecules have a larger amount of electrons, and so will have bigger van der Waals forces. And lastly, how close the molecules can get to each other. So if molecules can pack really tightly together, then there's going to be large van der Waals forces between them. If, on the other hand, molecules are quite branched, they have to be quite far apart, then the size of the van der Waals force is going to be smaller. Okay, so there you have it, van der Waals forces in a nutshell.